Okay, my 8th graders, here's how to do Kirchhoff Voltage Law with one loop. Okay, so here are the steps. So you have a circuit here. First step, assign the current to each loop. You have only one loop here, so there's one current. If you have two loops, it will be two currents. Now, the way you assign the current is arbitrary. It doesn't matter. So teachers do it, engineers, scientists, they all do the same way. So the current here can either go clockwise or counterclockwise. Okay, for me, I prefer clockwise. So let's just go clockwise. Okay, clockwise. It doesn't matter. If you solve it and you get a negative answer for the current, it means that the current actually goes counterclockwise. Okay, here I assume it's clockwise. So if I get positive answer, it means my assumption is correct. It doesn't matter. Okay, everybody does it the same way. Okay, so we pick a starting point. Number 2, start at a battery. Then go around the loop, adding up all the voltage drops or voltage gains and set it equal to 0. This is KVL. That's the principle of KVL. The sum of all the voltage drops or gains in a closed loop is equal to 0. Okay, so let's start from a battery. Now, doesn't matter which battery. Let's just go with this battery. Now I pick a point below the battery, like this point, and I go across it. As I go across it, here, going from negative to positive terminals of battery, I gain voltage. So I gain 10 volts. Now, if you go from positive to negative, you lose voltage. So you lose 5 volts here. Okay, so I gain 10 volts, going from negative to positive. This is convention. So I gain 10 volts. I put it right there. And then keep going. Now I go across the 10 ohm resistor. Okay, resistor by itself resists the current. So it resists. It takes energy out of your circuit. Okay, so it can be a light bulb, it can be a fan, or it can be a refrigerator. Doesn't matter, but it takes energy out of your circuit. So it will be negative. What's the voltage drop? Remember, V equals to Ri, Rhode Island. Okay, resistor times current. Okay, so the resistance is 10 ohm times the current. We don't know. It's I. Okay, we just call it I. If you have two loops, then I1, I2. Here's just I, one loop. So it will be 10 times I, but it will be negative 10I. The negative comes from you losing the voltage, this voltage drop. Okay, keep going. Now 5 volts. So going from positive plate, the long plate is always positive, the short plate is negative. From positive to negative, you lose voltage. Right here, from positive to negative, gives you the voltage drop, which is negative. So put negative 5 right there, negative 5. And here, the last one, keep going. You got negative 15I. Negative 15I. So these are the voltage drops and gains in this circuit. You add them all up, and Kirchhoff said they will be equal to 0. Okay, so let's add them up. Okay, so you gain 10 positive minus 10I minus 5 minus 15I equal to 0. Then the rest is math. So if you solve this, combine the like terms, you get negative 25I equal to, okay, let's do it one step at a time, plus 5 equals to 0. Okay, 10 minus 5 is 5. Okay, so then solve for this. I will be equal to negative 5 over negative 25 is equal to 1 over 5. So for scientists, we prefer decimal. So scientists and engineers, 0.2 amp. Okay, the mathematicians may like 1/5, but let's just go with the practical answer, 0.2 amp. Okay, 0.2 amp. So it's positive. It means our assumption of clockwise is correct. Okay, so that's it for one loop. I'll see you next time for 2 loops.